Good afternoon, everyone. Welcome back to another Matthew 10 channel. So, remember the last time we said we're going to look at the nature of roots and the quadratic formula, or rather how to complete the square, right? Okay, so let's first look at the nature of roots, right? Let's first look at the nature of roots. What are you talking about by the nature of roots? So basically, when we are talking about roots, we are talking about x values. Have that in mind, right? When we are talking about roots, we're talking about x values. Now, the roots of any quadratic equation given ax squared plus bx plus c is given, or rather can be found can be found by x is equal to b plus the root b squared minus 4ac divided by 2a, or can also be b minus the root b squared minus 4ac all divided by 2a. Right, so this is how you find, rather those should be negative here, right? So this is how you find the roots of any quadratic equation, right? So this is a quadratic equation here. You can use this formula here, which is the quadratic equation formula, to find your the roots or your x values or your x-intercept in that case, right? Let's say the x-intercept, right? So the roots, as I said, are the x-intercept when the equation of the quadratic, the equation of the quadratic equation is equal to 0, right? So you can only find the roots only if this here is equated to 0. So that is how we find the roots of quadratic equation. We equate this equation here to be 0, right? Now the roots are the intercept. So if I have something like that, these are the roots here, right? Again, here I can say, well, these two here are the roots. That here is a root, right? So make sure that you understand, guys. It's very important to know what a root is, right? A root are the x-intercept, right? Not only the x values, but the x-intercept, right? When this quadratic equation here is equated to 0, that's when you find the roots of a quadratic, right? So for instance, they might ask you to determine the nature of roots of an equation, right? So there you are not asked to solve an equation, right? To solve like complicated questions, right? So basically, to find the nature of roots of a quadratic equation given as, of course, ax squared plus bx plus c. Remember, when we're talking about roots, we're equating this thing to 0, right? So we look at the value of the discriminant. So what is a discriminant? Remember, we said here x is equal to negative b plus negative positive b squared minus 4ac, right? All divided by 2a. So when we're talking about the discriminant, we're basically talking about what's in this root here, right? So that that is what you meant by discriminant, because this here, it has a massive effect on the x intercept, right? It has a massive effect on x intercept. Remember, we can have b squared minus 4ac, which is equal to 0, right? We can have b squared minus 4ac, which is less than 0, then we can have b squared minus 4ac, which is greater than 0. So what's inside this root here is called the discriminant, which is denoted as delta then, right? So which is, this thing here is denoted as delta. I can say, well, this is the same as that. So what is happening is that this here, what's inside this square root here, it changes the whole the whole effect of the graph, right? It says something about the graph, right? Remember, if x, or rather if my b, or rather my discriminant is less than 0, so meaning I will have a negative root inside there, right? I'll have a negative root which says something, which changes the whole thing now, right? If you put that on a calculator, of course we'll get a math error or something, right? You'll get a math error. So make sure that you understand these roots. So the roots, or rather the discriminant here, right? So when they talk about the nature of roots, or rather to determine the nature of roots, you have to understand these three here, right? Yeah, you have to understand these three things here, right? So basically, let's first start with the first one. So okay, let me just scroll down. If our discriminant is basically equal to 0, so what does that mean? It means that they are equal, rather two equal roots, right? There are two equal roots. So what I mean by that is, remember we said our quadratic equation is given as b as negative b squared minus 4ac all divided by 2a. So now if what's inside here is 0, right? Remember here we said delta is 0, so meaning b squared minus 4ac is equal to 0. So what will happen is I'll have negative b plus the square root of 0 over what? Over 2a, and I'll also have negative b minus the square root of 0, which is equal to 2a, right? Now you notice that the square root of 0 is 0, right? And then minus b plus 0 will be negative b over 2a. And then here, similarly here, negative b minus 0, that will give us negative b to a. So that is what we meant by equal roots, right? So when we put a positive and also when we put a negative, the roots will be equal in that case, right? So what does that mean? It means that, or rather, remember that here, given that this here is an integer, and my a is also an integer, right? So it means that now we have real roots, right? The roots are real, right? Because if I put the square root of 0, I will get a value of 0. If you plug this in a calculator, you will get a value which is 0, so meaning that is real, because 0, it is a real number, so meaning that is real. And then remember we talked about rational numbers. We said the rational number is given in the form b over a, where my b in that case is an integer, also my a is also an integer, right? So meaning this value here is also a rational, right? And they basically equal roots. So if they say identify, determine the nature of roots, so if I get my delta which is equal to 0, then the nature of roots is that in that case. So we have real, rational, and equal roots in that case. So if I can sketch this, if you can sketch this here, you get basically equal roots. So meaning we do have a root, right? So you get a it's not too perfect, so like that. So it will bounce off on your x-axis, right? It will bounce on the x-axis. So basically when you get my b, when my b rather when my discriminant is equal to 0, then we have real roots, rational, and equal roots, right? So that's the nature of that root, rather the nature of roots, right? So here you can see that it is bouncing off on the x-axis, right? So now we could say, well, the roots are equal there, right? The roots are common, right? They are common in that case. So it's very important to understand that. And of course, you can draw it in sad face. It can be anything, rather, as long as the roots are bouncing off on the x-axis. Oops, should be bouncing off on the x-axis. So hope that you understand what it's meant by the discriminant, or rather the delta. We basically mean that what's inside the square root on our quadratic equation. And then of course you equate that to, if it's equal to 0, then we have real roots, as I explained here. You can see that the roots are equal. This side here is equal to that side. We had rational roots. If you know the rational, if you watch my prior video, you will know what a rational is, and then they are basically equal. In that case, you can see the left hand side is equal to the right hand side in that case, right? So it's basically important to note that yeah, they're real because you get a real value in that case, unless if given that a is greater than 0, or rather not greater than 0, but a is not equal to 0, right? Yeah, so that is the first one here. Delta, if my delta is equal to, if they say determine the nature of roots, then you notice that what's inside this bracket here is equal to 0, or rather what's inside the square root is equal to 0, then my roots are real, rational, and they are also equal. As you can see that I did some sketching on the side there. Okay, so now let us talk about when my delta is greater than 0. So what is happening then, right? What is happening? So we're basically saying that, well, the b squared minus 4ac, this value here will produce a positive number, right? Whatever the value of b is, whatever the value of a is, whatever the value of c is, it will produce a positive number, right? That is what we mean by greater than 0, because a number greater than 0 is basically positive. If you look at the number line, right, you can see 1, 2, 3, and so on that side. And here you have -1, -2, -3, and so forth on this side, right? So these numbers on this side are greater than 0, and these numbers on this side are less than 0, in that case, right? Are less than 0. So make sure that you understand this thing here. Okay, so notice that this here will be a positive number, right? If my a, or rather my discriminant, is greater than 0, then I'll have a positive discriminant. Which, what does it mean? So it means that, okay, let's say this here is equal to let's say p. It means that I can have negative b plus the root p, right? P over 2a, and then I can also another root will be negative p minus the square root of p, right? P over 2a. Now notice something here. Are these two things the same, right? Are they equal? That's what we're going to ask ourselves. Are they equal, right? So basically these two things here, you can see that they are not equal, right? They are unequal. So that's our first nature of it. These two things, they are unequal, right? So for instance, if you say they are equal, then let us prove that. Let's say you have 2a here, and here of course we have b minus the root p over 2a, right? So we can take this here, right, leaving us with negative b plus the root p, which is equal to negative b minus the root p, right? So what we have negative. If I transpose this on that side, I'll basically get a 0. Oh, not negative 0, but yeah, I will get a 0, which is equal to 2, right? 2 with p in that case. Now, if p is greater than 0, remember we didn't include 0, we said greater than 0, so meaning p cannot be 0. So if I can put any value in place of p greater than 0, like 2 or 4, it is not equal to 0. So meaning that the roots are unequal. As long as this thing here is true, the roots are unequal, right? Hoping that you understand that one. Just hoping that you understand. So we have basically unequal roots, right? The roots are unequal. We have two roots that are unequal. For instance, you may have negative 2 and 2, right? Where it is 2, but they are unequal. This is a negative and this is a positive. So you might have something that looks something like that, right? We have negative 2, and also here you have 2. So the roots are unequal, right? They are unequal. So they are real, right? But as long as we're getting a number on our calculator, the roots are real, right? So meaning that's our nature of root again, the other nature of root, right? Now, if you notice something here, it depends, right? So if you can ask me, are the roots rational or irrational? Well, it depends on what p, the value of p is, right? So if p is a perfect square, meaning I'm talking about 4, 9, all the perfect squares, right? What's the other perfect? Yeah, all the perfect square in that case, like 36 and 49 and all that stuff, right? So if p is a perfect square, then the roots, or rather the roots are rational. But if you get that p is not a perfect square, like if you get 2, 3, 7 and all that, right, then that would be irrational in that case. So it depends on the value of p, right? It depends on the value of p. But again, if delta is not a squared number, meaning a perfect square, the roots, if it's not a perfect square, then the roots will be irrational. If it is a perfect square, then the roots will be rational. So it will depend on what your p value is to determine this nature of root here. So yeah, the roots are unequal. They're also real, and then they can either be rational or irrational in their case, right? So hoping that you understand that one. And then the sketch of the graph, of course, as you can see that you have two roots, so meaning they have to be bouncing off. They have to be bouncing off to the x-axis, right? So you can get something that looks like that, right? As long as they are bouncing off, as long as you have two roots that are bouncing off the x-axis, right? Then my discriminant is greater than 0, right? I'm sorry about the noise. There's some construction happening, so I'm just hoping that you understand or hear what I'm saying right now, right? Okay, so moving on, let's talk about when the delta is less than 0, right? So when delta is less than 0, what is happening? So let us see something. Remember we said, well, negative b plus negative the square root of 2a. Now if let's say my discriminant is equal to negative 4, right, then I have something like that, right? So I notice that this here, if I plug this, no matter what the value of b and a will be, if I plug this on a calculator, I'll get something of I'll get this message here, right? I'll get a math error. So what does that mean? It means that the roots here are imaginary roots, right? You can say they are non-real, or they are imaginary roots, right? You can say they are unreal or imaginary roots, right? Because you do not have any roots in that case, right? Because this will give you a math error, right? It will give you a math error, so you have no roots in that case. So we're saying that they are imaginary because when you are dealing with complex numbers, you notice that you can be able to change, rather you can be able to calculate that value there, right, when dealing with complex numbers. But again, here it's non-real, and of course they are they are imaginary, so meaning there's no x-intercept, right? There are no x-intercept. If there are no x-intercept, what does that mean? Well, it means that my graph is floating, right? It's floating in that case. It's on free fall, so right, it's floating, right? It's floating just like that. So that is how the graph would looks like. It will look like when it does not have, of course, the x-intercept, right? It will be a floating graph, right? So yeah, that's it for the nature of roots. I was just hoping that you understand what, remember we discussed what a discriminant is. We said that discriminant is a value that is inside the square root, inside the square root of a quadratic equation. Being said, this value here, inside, that's our discriminant, right? And we talked about its characteristics when it's greater than 0, when it's equal to 0, and when it's less than 0. What is the nature in that case, rather the effect of the discriminant on the graph, right? You can see how it changes the graph, so it has a big effect. So just hoping that you understand that. And of course, my next video we'll be looking at how to complete a square, right? Remember we talked about if you are given ax squared plus bx plus c, you have to change it in the form x plus p squared, or rather p raised to the power 2, and then plus q basically. So this is our next video here. We'll be looking at how to complete the square. So thank you for watching this video. I hope that you understand the nature of roots, and if there's anything again that you did not understand, please comment down below and share the video. Hit that like button. I'll catch you later.